Hey, my name is Swam. I'm currently a mechanical engineering student at Gwinnett Tech. This is Spooky. It's a humanoid robot project I've been working on for about 7 months now. I'm gonna be using this channel to sort of document my progress of the robot. A little background information about it is that I started making it in around April 2025. Um, Mainly for fun, but to also see if I can beat multi-billion-dollar companies at making robots. It's a solo project, so I'm working on the mechanical engineering, electrical engineering, and computer programming parts by myself. Right now, I'll just go over the mechanical engineering progress and details that I've had for the past couple months. So I have a Creality K1 SE, which I used to 3D print all of its parts in PLA. I have most of it done in PLA except for the sole, which is in TPU. I have like 0.4 millimeters of the sole in TPU to basically help it walk even in a slippery condition. I used 80 kilogram torque motors for its knee and its ankle joints. I used two 80 kilogram torque motors for its hip joint because it has two degrees of freedom. I basically have like two servos sort of stacked on top of each other with a rod passing through a bearing in the middle. It facilitates movements for pitch, which is front and back, and yaw, which sort of rotates the leg about its axis. The bearing mainly is to prevent any unexpected roll movements, which is to the side. The ankle and the knee only have 1 degree of freedom each, just to keep the design basic mainly. The shoes are a bit more detailed because it consists of three parts. The bottommost is the TPU sole for better walking conditions and just to provide grip for the robot. The topmost layer is the actual shoe, the body of the shoe, which consists of a LiDAR sensor. It's basically going to be working alongside the FSR sensor, which is going to be placed in the middle layer, which is also a sole, like the top part of the sole. So the FSR sensor can take weights from till up to like 20 kilograms or about like 44 pounds or something. So what it's going to do is when the robot is walking, it's going to take the measurements from the FSR sensor, the pressure sensor, and it's going to sort of have like a check condition where if the leg is on the ground, it's going to take readings from that LiDAR sensor to detect what's in front of it. If both the legs are on the ground, it's going to alternate between the sensors for like 0.5 seconds in each. It's going to have it's gonna have 150 kilogram torque motors for the torso joints. The torso joints are basically the ones right here, which make the robot lean sideways or front and back, which is mainly gonna be for balancing for when it's walking. Since I don't have any movements like roll movements in its ankles to balance it, I am mainly heavily going to be depending on its torso for when it's walking. But I do believe fewer angles would do the trick mostly. I'm going to be running Isaac Sim trial runs this week and next week to see if everything works perfectly and as planned. I think that's about it for the mechanical details and progress of the robot over the past couple of months. I did have another standing model before this one, but I had to omit that and like start from scratch because the hip joint didn't have the bearing then, which made it so it would fall on the side even with like the smallest steps or the smallest gate. The knees were also supported, and also the motors at the knees and the ankles were about 40 kilogram torque, which was fine, but it was not gonna be when we switched to like when we add the whole torso, because this is just like the bottom part of the torso and there's gonna be one more section of it on top, and then there's gonna be the arms and the head. So that's why I've created the motors. And yeah, I believe that's about it for the mechanical part. Okay, and for the electrical part, I have a 4S 4P battery, which is gonna be sort of in the middle of the torso to support the center of mass so it doesn't like toss over to one side. It's gonna be giving out 16.8 volts. I'm gonna have 4 buck converters. That's what I have so far, since I don't have the arms yet. But the first buck converter outputs 8 volts, which goes into another terminal board, which is basically powering all the servos in the legs, which is the ankles, the knees, and the hips. The second buck converter is for the neck mechanism, which I don't have done yet, but it's gonna be done in a couple of weeks. The third one is the one that goes to Raspberry Pi, which gives out 5 volts. The Raspberry Pi connects to these 4 things. Again, for now, like it's gonna be more eventually. We have the FSR pressure sensors, which is in the sole, as we talked about earlier. The IMU, which is fit in the pelvis. It's for balancing. The PCA 9685, which is for all the servos in the body, basically. What this board does is for any servo motor, you need 3 connections. So one of them is a positive, a ground, or a negative, and a signal wire. So the servos get the positive and negative from right there, and the signal wire is the one that goes from the Raspberry Pi to the servo, which basically tells the servo which way to move, or how much to move, or how long does it have to hold it. The last one for now is the LiDAR, which is again going to be in the shoe to detect any obstacles in front of it. The final buck converter we have is the one that's connected to the 2 servos, which are 150 kilogram torque for the torso. They output somewhere between 10 to 12 volts. And the battery is also connected to a BMS, which is going to be used to charge it. And it also like provides data to the Raspberry Pi via Bluetooth, so it can know when it's getting low on charge. And Raspberry Pi can it's also going to be connected to a speaker and a mic, so which is going to be connected to the AI of the whole robot, which is called Spook AI. So how that's going to work is it's going to have 2 USB connections for the speaker and mic. Horrible handwriting, but okay. So these 2 things are basically going to be used for the voice commands, which Raspberry Pi doesn't run on its own. It just sort of hosts an SSH signal for now, and it bangs back to my computer, which runs the Llama program, Llama 3 for now. So it bangs to the Raspberry Pi, and it can respond from like the speaker through the USB connection. So even the Raspberry Pi and the ROS2 in it, they're doing all the mechanism that's done in the board. The actual brain of the robot, which is called Spook AI. Spook AI. So that is run on my computer for now. And yeah, so the BMS is connected to the battery, and there's 2 more wires coming out from here, which sort of connect to the charger, which is going to be like in the side of the robot's torso. So the aim is so I could plug it in itself to self-charge, since it's also going to know when it's low on battery from the Bluetooth connection. And yeah, I believe that's about it for the electrical parts too.